Hi everyone, welcome back to the channel. In today's lesson, I'll show you how to resolve forces using the vector polygon method right here in AutoCAD. This is useful in engineering construction and even carpentry, anywhere where forces are acting on a structure. And by the end of this video, you'll be able to find the resultant and the equilibrant for a set of forces. As you can see here, we have a force diagram, all right, a simplified force diagram that is representing four different forces acting in different directions and also acting with different magnitudes or forces. As you can see, we have this orange one here pushing to my right. Then we have this blue one here. We have this white one here and this green one here for reference. Now, how do we resolve the forces? Now, we're going to be using the graphical method today, and the graphical method is using the vector polygon diagram. But before we get into things, we need to select a suitable scale. Now, what does this scale use for and what does it mean? All right, as you can see, for each one of these forces, we have F1 here and F2. You'll see at the end we have a value. Here we have 6, here we have 5, and here we have 4. These values represent forces. In future study, these values will have a unit beside it known as Newton or kilonewton. Here, because it's the first time we're touching on this, we're not going to be adding those units of measurement. Simply note that this means 6 units and this means 5 units of whatever force it may be. Now, that there is represented by this section here. Scale unit, 1 unit. So here we have 6. Now, what does this say? For every 1 unit, that will be equal to 6 centimeter in real life or wherever you're drawing. So for every 1 unit, it means that it's going to be multiplied by 10 centimeter. For example, in this case, this 5 units will be equal to 50 centimeter because you multiply it by 10 centimeter. This 4 unit will be equal to 40 centimeter. This 6 unit will be equal to 60 centimeter, and this 3 unit will be equal to 30 centimeter. But depending on your units that you're using, it might vary. This could be 1 to 1, or 1 unit of that will be equal to 1 centimeter. It could also be 2 to 1, 1 to 2, 1 to 3, 1 to 5, so on and so forth. You decide the scale that you want to use. Now, how do we convert this to our drawing? We must first redraw our forces, all right? And we'll redraw our forces with the respective magnitude or forces. For example, this line here that represents F3 will be equal to 40 centimeter. So we're going to be redrawing this line, but it's going to be equal to 40 centimeter. So let's go ahead and draw that one there. So I'm going to go ahead and type L, enter to my right here. And I'm going to draw a horizontal line that measures 40 centimeter. So this is now 40 centimeter. Let me match the properties so you can see what's going on. I'll now draw this green line forces here that will be representing that one there. So I'm going to draw a line down from that point there. Let me turn on OSnap. Now this one here is 90 degrees down, so I'm going to draw the line perfectly going down. Now this one here is 3 units, so it's therefore going to be measuring 30 centimeter. Let me again match the properties so you can see what's going on. Now we need to draw this one here. Now what angle is this from this one here? Now we can check the angle by simply using our angular measurement here and clicking between the two lines. That's 58 degrees. So I'm going to now draw a line from this point here that is at an angle of 58 degree. All right, so how am I going to do this? I'm going to enter the angle that I'm going to be drawing at. So I'm going to hold down shift on my keyboard, then select the greater than symbol. All right, as you can see there, then I'm going to enter the angle 58. That's what it was. Let me double check. In the future, you'll have the measurement on the sheet of paper or whatever that you're doing. So let's draw the angle. 58 centimeter, 58 degrees. So shift greater than symbol, 58 degrees. All right. And then you could go enter, and what that will do, it will lock the cursor along that 58 degree axis. Now you can enter the length of the line, which in this case will be 50 centimeter, because we're using every 1 unit is equal to 10 centimeter. Now let's do the final line, which is on this side here, F1. Now what angle is F1? Let's check. F1 is, starting from here, it's at an angle of 135 degrees. So let's draw that one. Line, click at my base point, enter the greater than symbol, then enter the angle, which is 135, then press enter. Now my cursor is locked in that direction. I am going to be entering 60 centimeter. All right, now all my lines are drawn to the scaled value or the specific scale that I'm using. So let's go ahead now and match some properties. So this now will become blue, and this one here will remain white. All right, and from here now I can easily transfer my labelings over. So for example, this here and this here, I'm just going to simply copy these here now to CP and copy them to this one over here to make things simple. All right, so now it's time for us to do our vector polygon. Now how do we do this? Now you remember from the previous video is that we go head and tail. Now what does this head and tail mean? We're simply going to be drawing the forces from head to tail. Which part is the head and which is the tail? This portion up here at the end of the force is always the head, and the part that is at point P is always the tail. Now when you're creating your force polygon or your vector polygon, you should always ensure that the one that you're creating or the polygon that you're creating, all the forces should be parallel or at the same angles relative to the originals over here. Now in AutoCAD it makes things a bit easier for us. What do we do in this case? We can simply copy the forces and then we'll have a perfect replica, angles, properties, and everything. So we start things off at force 1. So let's copy force 1. CP, and we're going to place it at a random point somewhere over here. So that is force 1. Next, we go to force 2. Force 2, you're going to copy it, still with your base point being point P here, and you're going to place it at the head or at the end of force 1. We repeat the process for force 3, where we simply copy force 3 with our base point being right here, and I'm going to place it at where? The head of force 2. Then I'm going to copy force 4, and I'm going to make my base point still point P right here, and I'm going to place the end or the tail of force F2 or force 4 to the head of force 3. Now you realize that it's literally forming a path around, creating something like an enclosed polygon. All right, now this force is incomplete It's not a seal or closed polygon. Now this is where we close things off. How do we do this? We simply draw a line from the end of force 4 to the tail of force 1. Now this line here, and I'm going to switch things around and change the line type to that broken line there. All right. Now the direction that this force is acting in is that it's acting along this direction here. Let me see if I can show you. CP, copy this here and place it somewhere in the middle here, and I'll rotate it for you so you can see. RO, my base point there, and yeah, I'll eyeball it. MA. Okay, so as you can see, this resultant force here that closes our polygon is going in that direction. All right. Now you see this force here, or this distance here, the distance from, or this force here, this is our resultant force. I'm going to call this your resultant force. This green line here, this green line here, not green line, but your yellow line is your resultant force. All right, this is your resultant force. This line here, this is your resultant force. Now, this resultant force is also your equilibrant because this is the force that pretty much cancels out everything else. Now, we can know exactly the value of this force because as you can see here, this was 5, this is 5, 6, 4, and 3. All right, so whatever force that is acting here has to be canceling out everything here. Now, how do we find this value? We simply measure. So we measure this line here to find out our equilibrant force. Now, based on what we know that for every 1 unit, all right, that is equal to 10 centimeter. So it simply means that for this 10 centimeter, we need to divide it, this 60 centimeter that is, we need to divide it by what? 10 centimeter, all right? And when we divide it by 10 centimeter, we're going to get 6 as our forces, as our force. Now, where are we going to put this? We're going to take this equilibrant here, and I should write equilibrant as well, because this force here is your equilibrant. And let me see if I can spell this correctly. Equilibrant. So this is your equilibrant force. So let me see if I can RO to rotate it. So this is it. Let me scale it up a bit. Let's make it twice. RO. All right, so this is your equilibrant force. Let me match the colors for you. So that is your equilibrant. Now, what I'm going to do to solidify things is that I'm going to take this equilibrant line, all right, and I'm going to be placing it. I'm going to be placing it on my force diagram here. So this force here, when placed on our force diagram here, this equilibrant here, we now know that the force is acting in this direction that basically cancels out all of these here. So this is the resultant force if you want to think about it like that. All right, so this is now our fifth force. All right, and this fifth force measures 6 units. There you go. Now, some of you may be wondering, how do we do this in real life, and how would we do this if we're doing it on paper? If you want to see a video like that, comment down below and I'll be more than happy to create a video explaining how you'll do that in AutoCAD. So let's summarize. In many real structure, forces act on different parts and do not meet at one point. Now, we often use Bow's notation to help us to do so in terms of labeling the forces. Now, whenever we're going to be drawing forces, there are some stuff that we need to do. We need to draw the known forces. That's the first thing. We're going to draw what? The known forces that we have. All right? We're going to, after we draw the known forces, we are going to create our vector polygon over here. This is our vector polygon. After we've created our vector polygon, we're going to close things off using our resultant, aka our equilibrium force. Then we move this resultant force to our force diagram to close things off. So in final, this over here is known as your vector, all right, polygon. Vector polygon. Alright, so we have our vector polygon here. Let me scale this up by about 3. Alright, so this here is your vector polygon. Alright, I hope this video was helpful. Please remember to go ahead, leave a like, share, and subscribe. If you want to see me dive into this even further using other examples, please comment down below and I'll be more than happy to do so.